It actually considers IMG elements, video elements where the poster is used, and block level elements containing text nodes.
Today we're talking about the largest contentful paint.
Woo.
One of my favorite page speed metrics, lighthouse metrics. Dominic, what is the largest contentful paint? Do you want to answer that, or should I go ahead?
I can read it.
It's fine.
I can read the definition, right? So
yes,
let's start with that. So the largest contentful paint, LCP, is an important user-centric metric for measuring perceived load speed because it marks the point in the page load timeline when the page's main content has likely loaded. A fast LCP helps reassure the user that the page is useful. So, what does that mean?
Yes. It's something that was introduced in order to support the UX behavior of how, or the UX impact of how a website loads, right? That's how I understand it, and which was for me almost felt like a pivot point of the page speed score metrics, because until a certain point, page speed scores seem to be a lot about the pure technical things, and it was very technical terms like time to first byte, time to interactive, and many different metrics that were hard to understand from a user point of view, but you had to understand from a very technical point of view. The largest contentful paint is something that I feel is actually rather easy to understand for everyone. It is about how quickly the largest thing loads on a website. And it assumes that the largest thing that is shown within the viewport when you load a website, that this is the most significant thing or has the most significant impact on how the loading behavior of the website feels to you. And that's where I think PageSpeed got a lot more attention to thinking about how the loading behavior impacts the impression of UX to the user. But it's also just simply said it does have an impact, because the quicker something loads, the faster you can start using the page, right? The faster you can get what the website is about, what the owner of the website is trying to tell you, or what the content that you're looking for is about, and if that's what you've been looking for. So what is this largest contentful paint element in the viewport above the fold typically? What could that be?
Well, a lot of the times if you have in a certain type of websites that we most of the time do, you have so-called heroes, like page headers that consist of a large image. And in these cases, normally the image is the element that causes the largest contentful paint, right? Because it covers most, if not all, of the viewport. That's then quite easy to determine. But it's not limited to images, because it can also be text nodes, or any other, what else is there? An image,
videos,
text, videos, an audio element,
animation,
an iframe
to some extent, an iframe.
Basically any HTML element, kind of. However, what maybe you can help me is what is considered a text node? Is it just one node that is purely a text element, or does it also count for children? And if so, only if it has text children? Do you actually know?
I think I would have to look that up in detail. But from my experience, what we have, I think, also currently on our Flint website, is that the H1 that is within that hero component is the largest contentful paint element, and that is one text node, that H1 text element. And that is great, because typically if you think about how quickly things are loading on a website, you want the largest contentful paint ideally to be, the fastest loading. It should load according to the Core Web Vitals, I think, web.dev. They say below 2.5 seconds. That's considered good. If it loads faster for at least 75% of page visits, then 2.5 seconds.
By the way, oh no, go ahead.
And the fastest element is usually text, right? Because you got the font loaded already. You can influence the font rendering, like the font display. And then the next fastest kind of, I'd say, is rather images. And then only stuff like animations, iframes, and videos. So to have a great largest contentful paint, a fast one, you should definitely try to have text or images as the largest contentful paint element. And if the images, that these are optimized in terms of the sizing, the width and the height, and being optimized for the screen resolution and so on. And you should generally try to avoid loading videos, iframes, and animations for mobile scores, right? Because also we on our website, we do have an animation inside of the header of our website. But on mobile, that is not above the fold, and that is not the largest element in the viewport. So that this doesn't kind of hurt our score and more importantly, like the overall experience, because the largest element is the text, is the headline. This is the most important one. So first you got to think about what is actually the most important thing I want to show to the visitor. And when a website does have, for example, a large background image and then text over it, it could also be that depending on how you code that also, that the largest element would be the background image. But at the same time, is that really the most important one? I think not. It's probably still about the text. So the largest contentful paint scores can also be influenced by design, or typically they are just like influenced by design, but also by content management, depending on how long, for example, your H1 headline is. It could be that this is the largest contentful paint element, or if it's like shorter, then it could be the image that is down below, because that pops up into the visible above the fold viewport.
Yeah, and just one thing I wanted to add is because there are actually in the Google documentation about LCP, it says what elements are considered, right? So it actually considers image element, like IMG elements, then image elements inside an SVG element, video elements, where the poster is used actually, an element with a background image loaded via URL, and block level elements containing text nodes or other inline text element children. So it's actually not everything. So no iframes. Also an SVG is, I guess, if it's just an SVG without an image element inside of it, it's not considered. So only if you, so images and text nodes, right? Yeah.
And when it's a video, then it takes that
the poster
image as well. Right, but that poster image, like you can't optimize that as well as an image with source set, right?
Well, it depends on how you implement it, right? Yeah, but like if you just take the default, what is the poster image of a video? We always implement it differently, right? We implement the real image, and then on click we show the video.
Yeah, because like that's interesting. We're discovering that ourselves just now, because right, as you say, typically we actually don't use regular video players on a website. It might be an exception to the rule when we're using it just as a showing an animation running in the background or something like that. But even then, we try not to use videos typically, but we rather use Lottie files with After Effects exports and so on. So typically when we are loading a video on a website, then it's an embedded video from YouTube or Vimeo. And then we don't load the actual video player, but we only load an element with an image tag on top to show a customized poster image. And once you click on that icon and that image, then only we start loading the actual iframe element. That's for performance reasons, but also for data privacy reasons, because only then we need to check for allowance and ask like the user if it's okay to load that video player. But yeah, what I was thinking about like typically was like these large background videos that would auto load and so on. I feel like it should have a negative impact on the largest Contentful pane, but I at the same time didn't test that in detail. Generally, I think it's safe to say again, like to think about, or that you should prioritize the actual appearance. Try not to optimize just for a score according to the current regulations, right? Because those might change, and not that it's not that they might change, but they definitely do change. Just like they just changed with Lighthouse 10, right? We just made a video about that, and significant things change. But I think it's better for the long run to think about what PageSpeed Score and Core Web Vitals are trying to achieve, and then to implement best practices. And with the largest Contentful pane, it's very obvious. It should be that the largest element that is visible should be the quickest to load, and you should try to optimize to load for that as much as possible. So for me, a large background video in the background is just not an option, no matter if PageSpeed measures that or not.
Yeah. Especially on, like, we're talking about mobile, right?
Yeah. That's the thing. Like I like when I was talking about it, I was actually kind of thinking about, like, I had this picture in my head about how there's like on desktop a large background video, but actually it's always about mobile, because we think mostly about mobile PageSpeed scores, or these are the kind of the only relevant ones these days. But it's also like if you have a large background video on desktop, you tend to have that on mobile as well, right? And you should avoid that.
You definitely should avoid that. Like, not only loading times, but also the amount of data that is transferred usually. And I know in some countries it doesn't matter where all of the people have like data flat rates, but we live in Germany, a wireless, a cell phone, a third world country. So kind of where data is expensive and mobile phones are slow a lot of the times.
Yeah. That is true. Yeah. What other things and strategies?
Please. Like I just a new Blackhat PageSpeed optimizing technique came to my mind. Maybe let me know what you think about it. So would it be possible to, if you have a large background image that spans like the entire viewport, to split it up in multiple images with the same source set, and then just display different parts?
To have tiles, like...
Yes, exactly. Like a Google map.
Yeah.
So we're tiling the image. That would work, right? If it's multiple elements.
With the intention to hack the algorithm. Yes.
Yes.
I have no idea, but also no interest to find out about that, actually. But it might work depending on how they implemented the technology for the test. From black hat strategies to white hat strategies, what can you do to optimize the largest Contentful pane? I think when it comes to text, is there a lot to optimize?
Font loading. That's like the thing. But I think the one thing that we've also talked about in the past was the issue with the lazy loading images that are above the fold, right?
Mm-hmm.
And this is exactly where the problems come in, because when you have an image that is your element that causes the largest contentful paint, you want it to be loaded as fast as possible. And lazy loading will slow down the initial load, of course. And if it's in the viewport, like if it's above the fold on like initial page load, then you don't want the image to be loaded lazy. And then, of course, you can optimize images even further, reduce image size using modern image codecs or image formats even, making the image smaller, like redesigning, like not having a full width image, but maybe have image text next to each other. So you only have half of the viewport, or things like that. That could also be an option.
Exactly, but like you should not lazy load an image above the fold, but try to load that immediately. In Chrome, there's an extra attribute now that they introduced, fetch priority equals high. So you could say, yeah, this is really important. So you could stress additionally that this should be the LCP element. We had a little discussion about this internally, and we couldn't agree on if we want to implement it, because it's just Chrome kind of, and no other browsers committed to that. And so we didn't all have the same opinion, and said that we didn't feel like we have to make a decision to support this right now by default with Flint, but we are definitely gonna stay on top of this and up to date with if other browsers start to support that as well. Optimizing the size, optimizing the image with image source set and so on. We talked about that in a recent episode about perfect responsive image size and so on. I think this all kind of has been clarified already previously. But I think the bigger challenge for us with a flexible component system with Flint, for example, is also that, how do you determine if an element is the LCP element and should not be lazy loaded? And there can be multiple strategies. The one that we just decided to do is that we're just going to leave it to like the type of component that we expect to be the hero on a website. For some pages, you can determine that very well for certain templates where you know this is a fixed header element and you know it's going to be the LCP element. But for dynamic components on dynamically created landing pages where you can drag and drop components, it might not be that clear. But if something is what we call a hero component, it's more safe to assume that this should or will be above the fold and should not be lazy loaded.
And just to be clear why this is an issue, because we could just add an option, right, to every component that has an image and say, please do not lazy load the image, or this is the first component on the page, or like this is a above the fold component or something like that. But the issue with that is that for all the lazy loaded images, we rely on auto sizes attribute, or the functionality from this lazy sizes library that we've talked about in a past episode. And having the option to not lazy load would mean that we needed to write the sizes attribute for all of the images ourselves again, and this would then again be a lot more work for customization, and also be a lot more error prone. It would probably cause a lot more errors or regressions in other situations. So that's why we don't do it.
Yes. Yeah, right. So, right, I'm just thinking again about how we implemented that. So to recap on that, we said that for the largest contentful paint, components, images, we're writing the sizes attribute ourselves, right? And we would need to write that sizes attribute also ourselves for other components if we want to have that option. Right, and that would be very hard, exactly. And we could, well, then you could say, why do you have to do that? You could still use lazy sizes and JavaScript. So what's the problem with that?
You mean like lazy loading above the fold images?
No, it's not like lazy loading. Like we had this option of like not, we have this option that the image gets not lazy loaded, but only using lazy sizes. But still that would happen at such a late point in time that then it's kind of like lazy loading, right? Already.
Yeah, it would be actually the same. But
so we
like what we have experimented with, because this is also like an issue in the lazy sizes GitHub repository. There's also an issue about that. That you can split up lazy sizes and load it like first, maybe even render blocking or inline the lazy sizes for doing that, and then having lazy sizes determine the image size. But like all of that in our tests has resulted in worse page speed scores, and so we decided not to do that.
And if we want to optimize something, we do not just want to achieve 70 or 80% of what can be done, but we want to get at least as close as possible to the perfect solution. And
what's also like the case for most of our hero components, the sizes attribute is actually quite easy, right? Because it's usually like 100 viewport width minus the padding on mobile, or and then a max content width maybe as a maximum. So
and of course, like use modern image formats and stuff like that, and use caching and all these kind of best practices when it comes to image optimization anyways on a website. Go check out our other episode if you want to learn more about image optimization for responsive images. But what else can be done for fonts? I just opened the web.dev font best practices. We should put that in the show notes as well. And they basically explain everything and a lot. I try to sum up maybe some of the most important things is like when optimizing for fast font loading, the best way, the fastest way is to use a web safe system font. But most of the times you don't. Most of the times you use a custom font. And if you're like us in Europe, and then you don't want to load fonts from Google Fonts directly, but load them on your server directly. So all the external pre-connect CDN stuff is not that important, but you should use like a modern font, like use WAF2. But this is also more for me like the basic stuff. The more advanced stuff is like, or it can get more tricky, is a font display strategy. Because this determines on how the browser should, at which point the browser should kind of try to swap the custom font for the system font, or if it should not swap it at all, but just like have a placeholder and so on. Like there's font display auto, block, swap, fallback, optional, and so on. And the interesting thing about this is I feel that while some of these will result like in a faster display of the typography by, for example, using the fallback font, when you use that at the same time, you might run in danger of getting CLS cumulative layout shift, because the switch of the fonts might cause a layout shift. And so it's very important that when you're using this like a fallback font that gets displayed with a rendering strategy, that you try to match your fallback font as closely as possible to the actual custom font that you are using.
Yeah. And for that, we actually learned something new recently, right? That you best, because what we did before was always we specified or we used like at font face, right, to specify a new font face and use that as the font family, and like directly after it, we comma separated all the fallback fonts, right? But this way, like, you don't have any control over these fallback fonts. So what we did then, or what we learned, what you can do is you have like your normal font, then comma, and then like your font dash fallback or space fallback or something like that. And then you declare another font via add font face that is then based on the system fonts, on these fallback fonts, but also where you can set additional font parameters. Like, I don't know, you can set like font weight and some specific like add font face properties in order to maybe play around with the letter spacing or things like that.
Yeah.
I think unfortunately you cannot set letter spacing directly. But yeah, you have to use other properties to do that.
Yeah. Yeah, that's a bit of a pity. Like I also learned that in the web dev article, they're also talking about a new attribute size adjust to help with this as well, like where you can adjust the overall size of a font, of a fallback font, for example, with this strategy that you just explained. But this will just like resize the whole font. And most of the times, like it's a lot also about the kind of the letter spacing, or like how wide a font renders, that this has a huge impact on the CLS, because the CLS happens when there are in the custom font, the words are rendered longer, then they break into more lines, right? And then this additional line would cause that layout shift, and that's what you want to prevent. So while I feel the size adjust is a little helpful, I think I would like to have more like a strategy where you can size like horizontal and vertical sizing, kind of like XY with background sizing and so on, just like stretch the font a little bit to some extent. There is a font stretch CSS property actually, but and it takes like also percentage values, but I think it doesn't also have like X and Y values, or how does that actually work? I think it is. I didn't try it. No, but I think that's also not doing that, what I want. Yeah, it's tricky. I think the best solution of what we found out is just like try to go through all kinds of fallback fonts and try to match that one which has the most accurate rendering similarities. This might not be design-wise the most accurate. It might have a little different appearance, but from a performance point of view, I would rather trust that more than 90% of people have a fast enough connection to load the custom font, and then I care more about the similarity of experience and the similarity, like to prevent the layout shift, than the other things like exact font appearance, design-wise appearance.
Yeah, I guess the last thing you can do to speed up or to increase LCP is or increase the score for it, is regarding CSS, right? So maybe loading the critical path CSS inline, like splitting that up, or optimizing CSS, like minimizing CSS and so on. So that is usually also something that can be done, or in client-side rendered apps, optimize the JavaScript rendering for it.
Yeah.
Right?
Of course, like everything that comes before that that moment when the largest contentful paint element can be loaded has a big influence on that, right? If your server is slow, if the website is not cached, if you are not loading your scripts asynchronously in parallel, if there's a lot of bloat going and so on, this is kind of sounds like rather, yeah, sure, like get that right. But that's how like it feels for me. Like if all of that is bad, like, and not optimized, you can't get a great LCP. So do your kind of base work, your homework first with all those kind of optimization strategies. Yeah. And then also typically you will have a good LCP, I think, if you follow these more specific strategies in terms of prioritizing loading. So just make sure whatever is the largest thing above the fold gets the full priority and try to delay everything else as much as possible.
Yeah, and that's actually interesting. And I want to actually come back to something that you said at the very beginning, because you said that the previous metrics that were used to measure page speed were all like technical, and now the things are more like user based and so on. And I just want to stress that before, everything was like actually pretty easy to understand. Because it's easy, like when a page is fully loaded, yeah, okay, there are like events that you can either say, okay, when all the data is submitted, or when like a document is ready, or when nothing happens anymore, or something like that. And then also with LCP, things are much more relevant for the user experience, but also a bit harder to explain, right? And a bit harder to grasp, maybe. I think this is also pretty like interesting, and sometimes you have to think about it a bit more than just the simple metrics, these technical metrics. But you want to create the best user experience for the users, and not just something that is like a technical number to improve, right?
That's true. I just like these metrics that are more literal to understand, kind of, or where the concept is more simple to understand, and where one metric doesn't depend on too many other factors. Like we have right now things also like the first input delay. I would need to look that up on how that is exactly measured, from what point to what other point. Interaction to next paint. Yeah, once you understood that, that's also one that I think makes a lot of sense, but still it's more challenging to understand, and how you can influence that. Or the speed index. Like you need to learn a lot more, I feel, about these concepts and the technical details on from which to what point it's measured, and how you can influence that. Whereas the largest contentful paint is, for me, it's more like, okay, how quickly the largest thing loads. That's it from start to finish. It's not like it starts like after the DOM is ready until the point for then the JavaScript has loaded and executed, and it can first like be interacted, and then how fast the browser interacts and so on. This is just like more complex of a concept. That's still valuable, but more complex. And as you know, I like simpler solutions.